I told you that there's a build process in YOCTO. So you start from sources file and you perform a build. The core of this sources file, that is the reference build system, is Poke, a set of tools and packages that are gathered in layers. A good starting point to create a first fully featured build. Then the heart of the build process, Bitbake. So I just said that YOCTO is a collection of toolkits. One of these toolkits is Poke, that is this set of sources. But then you need a software that can glue together and handle all these different packages sources to create a final image. And this tool is actually Bitbake. That is a make-like, so from whom of you already know how to use Make, it will be probably quite easy to understand how Bitbake works. And it performs cross-compilation of the packages. What is cross-compilation? Basically, we are creating an operative system for embedded Linux, for embedded architectures. It means that we are probably performing the build and the customization on a machine that is different from the machine on which this operative system will run. So cross-compilation is exactly this, is compiling code for a computer system on a different system, called the host. Here's some historical concept. Bitbake is inspired by Portage, which is the package management system used by Gentoo Linux distribution, and it is co-maintained by both the YOCTO project and the Open Embedded project. Open Embedded is another project that provides a toolkit for embedded Linux operative system cross-compilation. You can find more information about it online as well. Now let's talk about how Bitbake works. We said that inside the Engicam BSP you will find this directory, that is the YOCTO source directory. Inside this directory you will have several meta layers, and inside these meta layers you will have the Bitbake recipes for different Linux packages. In these recipes there are the instructions that Bitbake follow to compile that specific package. So there will be a source mirror, and there are several protocols available to download the source code, and of course it can be both online and on the local system. There will be the dependencies, so in the recipes there will be the name of the other packages that have to be compiled to include the package in the final build, and other compilation or installation options. Another thing that you need to know is that during the cross-compilation, Bitbake generates as a first step the toolchain. A toolchain is a set of compilers for the target. So this means that before the compilation, Bitbake generates a toolkit that we use to compile the packages on the host machine that will be part of the final image. To summarize this concept, we can say that during the build process, recipes are used to track dependencies, performing native or cross-compilation of the package, and package the output of this cross-compilation to make it suitable for installation on the local or on a target device. And it is also possible to create complete images consisting of root file system and kernel.